Hi, I'm an old guy and I do maths. Today we're going to look at how we calculate a standard deviation. Now, for those of you who don't know what a standard deviation is, very briefly, it's a way of breaking up the range within a distribution of numbers or data. And it is a measurement from the mean, the average of those numbers. If a range expands, so does a standard deviation. It is inextricably linked to the range of the distribution. So let's have a look at this formula, which tends to terrify people who first see it. So the standard deviation, this thing here, is calculated by finding the square root of all of this. And let's just explain this. This symbol here, sigma, Greek capital sigma, is an abbreviation for the sum of. And what we are finding the sum of is every piece of data with the mean of the data subtracted from it, all squared, divided by the number of pieces of data minus 1. Now, this is a sample standard deviation. A population standard deviation looks slightly different. Now, you see all the elements here. Sometimes you see this written like this, which simply means that you're taking all the data from the first element to the last element and working on them. So this is the sum of the first to the last element in the distribution. So let's go to work. Let's take a set of numbers. 1, 2, 3, 4, and 5. We'll make this really simple. Now the mean of this is 3. 1 plus 2 plus 3 plus 4 plus 5 equals 15. 15 divided by 5 equals 3. So the mean, which is the sample mean, which is this symbol here, is 3. And what we do is we take all of these numbers. So we go 1 minus 3. So that's 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3. And we find the values of these and we square them. So 1 minus 3 is negative 2, but we are going to square that. And 2 minus 3 is negative 1, and we are going to square that. That is 0. 4 minus 3 is 1. 5 minus 3 is 2. And we're going to square those. So negative 2 all squared is 4. That is 1. That is 0. That is 1. That is 4. So this total here is equal to 10. And then what we're going to do is we're going to divide this by the number of elements, 5 minus 1. So that's 10 over 4. And that's going to give us a number. 10 divided by 4 is 2.5. That's everything in here done. So now all we have to do is apply square root to this. And the square root of 2.5, this is where the calculator comes in handy, is 1.58113883, which we can round to, let's say, 2 decimal places, 1.58. So the standard deviation of this set of numbers is 1.58. I hope that this demystified a little bit of the working for this. You don't want to be doing this manually for a large group of numbers, and what I've noticed in the textbooks recently is that the formula is coming back into fashion in secondary schools. It's been probably 20 years, I suppose, since I taught this regularly to people for fairly large clusters of numbers. It tends to be in the textbooks now just as a demonstration piece with one or two questions on how to do it. So if you get one of those one or two questions, this is how you do it. I hope you found this useful. If you did, please like and subscribe, and I will see you next time. Bye.